So in question number 16 on page 317, you're asked to consider two vectors, vector u with components 1 and 2, and vector v with components -2 and 1. And in part A, you're asked to show that vector u and vector v form a basis. Now, at the beginning of the chapter, the basis was described as any non-parallel vectors. So essentially, to show that vector u and vector v form a basis, you basically have to show that the angle between them is neither 0 degrees nor 180 degrees. Because if we have two vectors that point in the same direction, then the theta between them is 0. And two vectors that point in opposite direction have an angle theta of 180 degrees between them. 180 degrees. So essentially we want to show that it's neither 0 nor 180 degrees. Now we'll do this using scalar product. Scalar product is one of the easiest ways and most reliable ways to find the angle between two vectors, because in the algebraic approach we say magnitude of u times magnitude of v times cosine of theta, where theta is the angle between them. But this is also equal to the x components, xu times xv, multiply to each other, plus the y component, the y parts, so yu times yv. So we know both the the components of vector u and v, and we can find the magnitudes of u and v. Therefore, we can solve for theta, and if theta is 0 or 180 degrees, then they are not a basis. So let's start by finding the magnitude of u. The magnitude of u is equal to the square root of 1 squared plus 2 squared, and that's 4 plus 1 is 5, square root. The magnitude of v is -2 squared plus 1 squared, -2 squared plus 1 squared square root, and that's also square root of 5. And so what we have here is square root of 5 times square root of 5, and that's 5 cosine theta. Now let's find the scalar product using the algebraic method, and that's x of u and x of v. That's -2, so that's -2 plus 2 times 1 is 2, and that's 0. So we have 0 equals 5 times cosine of theta. Now if I divide both sides by 5, like this, I get 0 equals cosine theta. And if I take the cos inverse on both sides, I get theta, and that theta is 90 degrees. Now this was very obvious just by taking the algebraic approach. We saw that we got, here's the algebraic approach, we got 0. This only happens if the angle between these two vectors is 90 degrees. So we didn't even have to do this geometric approach, because as soon as we finished the algebraic approach, we saw we got 0, which only meant that we could have 90 degrees. So these two vectors, u and v, are perpendicular to each other. Not 0 degrees, not 180, that means they are not parallel, which implies, here's my implies, it implies they form a basis. They form a basis.